Hey guys, this is the video for homework for week number 7, although this topic is actually from week number 5. Which is topic 72J. So that's up here on my second side of my screen. Oh, I gotta share my screen. There we go. So you can see that here, where it's asking you to match this graph with the equation, right? So the equation's here, and then there's these 4 graphs down at the bottom. So I just wanted to re-explain this in a different way that I think was a little better when I started working with students. Basically, there's 3 different parts here to pay attention to. One of the things that's the easiest to see is that this number here that's by itself, this constant, so this is the constant. This constant is, it tells you where the asymptote is, which is a horizontal imaginary boundary in the graph. So it's represented in these pictures over here on IXL here with this dotted line to show that it's not actually a part of the graph, it's not a line, but it is a boundary that the graph tends towards. And you can see where it's at just based on where this number is. So if I'm looking, this says it's going to be at -5. So this is where it crosses the y-axis. So if I'm looking through the graphs I have some here at -5, right? But then I also have a couple here at +5. So that negative sign definitely means that this is going to have an asymptote at y equals -5. So it's going to be one of the ones where it crosses at -5 here. Okay, so that's one part to pay attention to. Another part to pay attention to is this number out front, which later would be something we call an initial amount if we're talking about like a situation with exponential, like a word problem or something. But this also tells you in a graph where it is above or below the asymptote. So it's either going to be above the asymptote or below the asymptote. So this is talking about the asymptote. And it's based on whether this is a positive number or a negative number. So it'll be above that dotted line if it's a positive number out front. It'll be below the dotted line if it's negative, because that negative sign essentially reflects this. It flips it over. So this is a graph that's going to be below the line. And if I look at the 2 examples that I was looking at before these 2, they are both below. So that part doesn't necessarily help in this situation, but it is part of the information I can look at. The last part is what's going on inside the parentheses. What are you actually multiplying by, right? Because as I change x, that's going to affect how many times I multiply 3. So if this is a 2, then it's just 3 times 3. But then if this is a 4, it's 3 times 3 times 3 times 3. So it depends, it really depends on the size, right? This is definitely going to affect the size. And so if this number is greater than 1, it's going to make a big number. And if it's less than 1, really, it's just dividing, because you're talking about like a fraction, 1/2 maybe. So it's like dividing over and over again instead of multiplying. So if this is greater than 1, it's going to be moving away. And if this is less than 1, it's going to be moving toward. And when I talk about moving away and moving toward, again, I'm talking about the asymptote. So if I look at what's going on with these 2 pictures, this is the difference between them. So as I move from left to right, so this is left to right here, like a sentence on the graph. For this first one, I start on the left side and I move to the right, and the number starts to move down, right? It's moving away from the line. It's getting further and further away as I go forward. Whereas this one is starting down here, but as I move forward, it's getting closer and closer. So it's moving toward. So that's the difference here, is that one of these graphs is moving away and one is moving toward. Since my number is a +3, it's greater than 1. So I'm looking for a graph that's moving away. So in this situation, I'm looking for the graph that's going to be, it's negative, so it's going to be below, right? So I'm looking for the below. For this one, since it's greater than 1, I'm looking for the one that's moving away. And then here, I'm looking for y equals -5. kind of hard to see with that yellow, but that's what that says. That's that boundary. So it is definitely the first one. It's moving away, it's underneath, and it's at -5. All right, so for this one, if I'm looking at this next example here, this one is giving me a graph. So if I'm looking at the graph, it looks like my asymptote, right? That's an important part. That's at -5. It is below, and it is moving toward, right? So it's below the asymptote, and as I move this way, it's getting closer and closer to the line, so it's moving toward it. So really that means it should have a negative in front and less than 1 inside the parentheses. So that's what I'm looking for here. So I'm looking for a -5 at the back, a negative number in front, which they both have, but then this one has a number that's less than 1 inside the parentheses, so that this option matches these criteria. Okay, so hopefully that will help you with the rest of it. As far as the work for this week goes, this is topic UEC, which I think many of you finished very quickly when we were going through it in class, because really you're just deciding, is it a straight line or is it a curved exponential line? And I mean, it's really just the difference between straight and not straight. So I'll let you work on that one. And then as far as tables go, I mean, you could definitely handle it this way by graphing. But if you're talking about trying to figure it out just by looking at the table, so this is topic LZF, where you have tables, you're really just comparing the rate of change. So you want to compare what's happening with Y to what's happening with X. If it's linear, it'll be a constant change for both. And if it's exponential, it'll be a changing change. Basically, it won't stay the same, it'll be different, and it'll be going up probably by a consistent amount. So if I look at the example that's over here on the screen, so 0, 1, 2, 3, 4. So I'm really just checking to see what the change is. So as I go through each one of these, I'm adding 1. But on this side here, if I check, a lot of times this is where I'll see the difference. So from 3 to 6, I'm subtracting 3, right, to get from -3 to -6. But then to get from -6 to -12, I'm subtracting 6. And here I'm subtracting 12. And here I'm subtracting 24. So there is a pattern here, certainly, but it's not constant. It's not the same number each time. So this is not constant. And so since that is not a constant change on both, then that means that this is definitely exponential. So this is an exponential table. Hopefully the next one they'll give us is linear. So if I look, I'm going to write this one up here. So for the second example, I have -8. All right, so if I'm looking at how to get from one to the other, this side all the way down is adding 1, just like last time. So I have a constant rate this time. This side, I'm adding 6 here, and then I'm also adding 6 here and here and here. So just like last time, I have, or just like with the X situation, I have a constant rate. And so really this is linear, because really what I'm saying is that this is the 6 over 1. Right? This is that slope idea. And so in this situation, because it's the same on both sides, that's why it's linear. It's all 6s here, all 1s here. This one is not linear because it changes. The change changes. Okay, hopefully that's helpful. The last piece of information for this was this growth and decay. And I think I'm going to go over this on an asynchronous day, and I'm going to count topic UKG. I'm going to do this one as extra credit. So I will teach a lesson on this one in class. All right, good luck. Let me know if you have questions.